So when we talk about symmetry, we can also talk about the inverse function. So the inverse function has symmetry across this line y equals x. And so we can reflect all the properties of the original function across this line. And basically this is when we switch x and y positions. So if you take a look at the coordinate here, this is 2 over 1 up. If we go 1 over 2 up, there is a symmetrical position here. And from these symmetrical positions, we can actually just sketch the symmetry through like this. Okay, and we can do the same thing with some of the other positions here. For example, negative 1.5, negative 4, we can go negative 4, negative 1.5, and that vertex should match. We could also match this vertex here. Okay, that's about negative 5, positive 4. So if we go positive 4 about negative 5, right about there, there's the other vertex. Okay, so I can sketch this graph. Okay, I can go through kind of like this, through that point, and then have my other vertex here. So that green graph represents the symmetrical graph of the black graph, or in other words, the inverse function. And the domain of the inverse is going to be the range of the original function, and the range of the original function is going to be the domain of the inverse. Okay, so if I take a look at my f of x, okay, so the f of x, the domain of this function is going to be from negative 5 to positive 5. Okay, so negative 5 to positive 5. Okay, the range of this function is going to be from negative 4 to positive 4. Okay, so if I take a look at the inverse function, so the inverse has notation like this. Basically what happens is the domain and range switch. So my domain then is from negative 4 to positive 4. So there's from here to here. Okay, from here to here is my new domain. And my range is going to be reflected by the domain of the original function. Okay, so the range is going to be from negative 5 to positive 5 there.